In this video, we are going to do some 3 questions here from definite integrals. And all these 3 questions are based on this. These two are very similar identity, right? If you're not aware of this identity or you may not have come across, we can even derive over here that, let's say, for example, the first one, we have 1 plus sine 2a. So what we know that I can write 1 as what? I can write 1 as cos square a plus sine square a. And I can write sine 2a. I can write sine 2a as what? Sine 2a as 2 sine a cos a. So that is 2 times sine a dot cos a. Now check here, we have a square plus b square plus 2ab. So that is what? A plus b whole square. That is cos a plus sine a whole square. Right. So now, as I said, that we'll be applying this identity in all these 3 questions. These one of these identity will be applicable. So let's say if I begin with the first one, let's begin with the first part here. We have to evaluate sin x plus cos x over whole under root sine 2x dx, and these are the limit. Well, the idea that I use here is that we have to consider t, right? The substitution, as you know, it's a question of substitution will be used. I'll think about cos x plus first. So cos x is derivative of what? Sin x. And sin x is the derivative of minus cos x, right? This is minus cos x. And I'm going to take it as t. And now check if I find its derivative, sin x derivative is what? Cos x, and minus cos x derivative is positive sin x, right? And that is dx equals dt. Next, you must be wondering what to do with this sine 2x. There is no t over here. That's what we are going to do. We'll be finding squaring both sides. So on squaring both sides, what we are going to obtain, that is sine square x plus cos square x, and then minus 2ab, that is minus 2 sine x dot cos x. And this is t square. And as you know that sine square x plus cos square x is 1. And you also know that sine 2 sine x dot cos x is what? Sine 2x. So I'll get here 1 minus 2, 1 minus sine 2x. And here from we'll get t. So I can write 1 minus t square as sine 2x. Now here onwards, we'll be doing the substitution. Let's check. What I'm going to do is I is equal to, we'll place the limit sometime later. First, let's begin with substitution. What I said that I'm going to replace this with the dt. This whole thing is dt. So I'll write this as 1 over, let's say dt over here. And we have already taken this as from here it is 1 minus t square. So this is going to be whole under root 1 minus t square. But then we have to change the limit. We have to change the limit, as you can see. That now check here. When x, that is the upper limit here. Sorry, it's the lower limit. So when x is equal to pi by 3, what are you going to obtain t as? It is sin x minus cos x, that is sine pi by 3 minus cos pi by 3 is equal to t. So what is sine pi by 3? That is, this is sine 60, which is root 3 by 2 minus half. So the upper limit will change here, right? The upper limit is going to change as, I can take LCM and write directly as root 3 minus 1 by 2. Likewise, if I change the lower limit, replacing this with pi by 6 here, what we are going to get, this is sine pi by 6 minus cos pi by 6. And what is sine pi by 6? It's half, and this is root 3 by 2. is equal to t. So the lower limit is going to change as root 3, is 1 minus root 3, 1 minus root 3 by 2. Now, once we have done with the substitution, we can do integration. And needless to say that here we will be, this is integration of 1 minus under root 1 minus t squared, which is sine inverse x. So now I is equal to the integration of this is sine inverse x, right? So this is sine inverse t, and the limit is going to be same as this is going to be root 3 minus 1 by 2, and below it's 1 minus root 3 by 2. Now let's place the limit here. The limit is for the upper limit is going to be sine inverse root 3 minus 1 by 2 minus sine inverse 1 minus root 3 over 2, right, after placing the limit. Now what I'm going to do, what is, you know that sine inverse minus x is what? Minus sine inverse x from your inverse trigonometric concept. So if I take minus common from here, we are going to get something like this. That's what I'm going to take minus common from here. So maybe I'll show you in the next step. I can accommodate here. This is I is equal to, this is sine inverse root 3 minus 1 over 2. As I take minus common from here, this minus will influence this minus and it will become plus sine inverse. This will also turn out to be root 3 minus 1 by 2. Now we can say that this is I will be equal to 2 times sine inverse root 3 minus 1 by 2. So I suppose we can declare this to be the final answer after evaluating. Now let's begin with the second question. Now in question number 2, this is not 1. This is question number 2 now. This is question number 2. All right. Now over here, the limit is 0 to pi by 4, and we have to integrate sine x plus cos x over 9 plus sine 2x. As I said in the beginning, these three questions that I have taken are very similar, and that's the reason I haven't erased most of its part of the first part. Now check here, here too also we have sine x and I can sine 2x, and I can replace sine 2x with this. And this is sine x plus cos x, and sine x plus cos x, before squaring it is t only. All right, no, it's not t. It is below 1, right? It is this one, right? This is sin x minus cos x, right? So we are going to take sin x minus cos x as t, and we are going to replace the numerator, that is cos x plus sin x dx, with dt, same as the previous question. So the only steps which is new over here will be what? I is equal to integration 0 to pi by 4, and I'm going to replace the numerator with dt, and the denominator as it is 9 plus 16, and this sine 2x should be replaced with what? Sine 2x, as you can see from here, can be replaced with 1 minus t square. On the next step, that involves simplification. This is 1 over 9. If I open the brackets, it's 16 minus 16 times t square. This is dt. I is equal to integration 0 to pi by 4, and this is 1 over, on simplifying, what I'm getting, 25 minus 16 t square. We got this. Right, this is dt. Can accommodate the remaining over here. So now what is I is equal to? This is integration 0 to pi by 4. Well, I'm making some changes over here. 25 I can write as 5 square. And 16t whole square can be written as 40 whole square. 40 whole square. Now, clearly, this is what a square minus x square, right? And if I tell you the integration of under root, sorry, integration of 1 over a square minus x square, it is what? It is 1 over 2a log mod a plus x, a plus x, a minus, it's a plus x over a minus x, right? So if I continue solving here, I can say this, I can write, it's integration straight away. I'm writing over here, it's integration. Well, we haven't changed the limit. Okay, fine. I'll deal with the limit later. Let's do the integration first. So if I integrate here, this is going to be what? 1 over 2a, that is 1 over 2 times 5 is 10. That's right. And then we have log mod a plus x going to be 5 plus x, and x is 40 over a minus x, that is 5 minus 40. But then check, I have taken or assumed this as x here, right? X is 40. So I have to divide it by its integration, that is its differentiation. So 1 over 40. So I can say we'll get I as 1 over 40, that is log mod 5 plus 40 over 5 minus 40. Now, as I said, we haven't changed the limit as we did in the first substitution. So what you can see that if I replace this with a lower limit, which is 0, so placing x as 0, so this is sine 0 minus cos 0, and that is equal to t. Sine 0 is what? Sine 0 is 0 and cos 0 is 1. So comes out to be minus 1. So I'm going to replace this with minus 1. 0 is replaced by this. Next, I have to place pi by 4. Now, if I place x as pi by 4, or x as pi by 4 here, what is pi by 4? That is sine pi by 4 is 1 by root 2 and 1 by root 2. So that will give you 0. So the limit here is minus 1 to 0. So it's minus 1 to 0 and minus 1 to 0. Right. Next, I'm going to replace these values with the limit. So what we will get, I is equal to, so I is equal to, this is 1 over 4a log mod, placing the upper limit, which is 0 here. So we are going to get this as 0 and this as 0. So it's 5 over 5, which is log 1. 1 over log 1. That's log 1. And then minus the lower limit, replacing t with minus 4. So it's 5 minus 4, which is 1, right? And applying the other property, here I'm going to get log minus 9. Log minus 9. So this is I is equal to 1 over 40. This is log 1, right? This is log 1. So log 1 will vanishes, as you know, log 1 value is 0. And if I open this bracket, we'll get log 9. So therefore, we'll say that this is the answer after solving the question. Now we're on the third of the 3 questions we selected here. Now what you can see that here this it is of integration under root tan x plus under root cotx. So we are going to convert them in terms of sine and cos. So this is I is equal to integration 0 to pi by 4. Now if I write under root tan x as under root sine x over under root cos x, it is under root sine x over under root cos x, and plus this is under root cos x over under root sine x dx. Now check, if I take LCM here, the LCM is going to be what? Under root sine x into under root cos x. I'm writing in a single under root. As you know, sine under root a into under root b is under root ab. And root sine x multiplied by root sine x is what? Sine x. So this is going to be sine x and plus cos x dx. Now check, we got the numerator as we have been doing in the previous questions. Now let's continue with the other part of the working. We are going to get I as 0 to pi by 4. Let the numerator as it is sine x plus cos x. What I'm going to do over here, I'm going to multiply by root 2. In this part is going to be under root 2. I'm multiplying this with under root 2 and dividing it by under root 2 over here. So this under root 2 divided, this under root 2 divided can be written over here also. So this is under root 2 outside. I can write outside the bracket. Let's deal with this part. What you can replace this with sine 2x. So this is going to be whole under root sine 2x. And as we did in the previous parts, here too is going to be same. This is under root 2. Now, what is that? We are going to do substitution. So let's begin with the substitution. We are going to replace this with dt, as you can see from here. There is dx as well. And like in all other parts, 3 parts, we are going to replace this sin x with this. So our questions modifies. Now let's say I place the limit later. First I'm writing this as 1, this as dt, and below it is 1 minus t square. Now the limit is going to change here the same way as the previous. Now the upper limit, which is, let's start with the lower limit, which is 0. So now when x is 0, placing x as 0 over here, this is not there, it's here. So placing x as 0, we are getting sine 0 minus cos 0. Well, sine 0 is 0. 0 minus minus 1 is going to be 1. So the 0 will be replaced with minus 1. And likewise, if I replace this x with 1 now is pi by 4. So this is cos pi by 4, which is 1 by root 2 minus sine pi by 4 is again 1 by root 2. So it comes out to be 0. So I'll write this as 0. So once we have changed the limit, now let's do the later part of the working, which is just the integration. As you know that integration of this is 1 over under root 1 minus t square, right? So be what? It should be, let's say the limit is minus 1 to 0 sine inverse t. So I'm placing the limit. Now integration sign is not needed. We'll just place the limit, which is minus 1 to 0. So now I is equal to root 2 sine inverse 0 minus sine inverse minus 1. So this is I is equal to root 2. Sine inverse 0 is 0, right? And this is minus. Now check here, sine inverse minus x is minus sine x. So I'll make this as plus, and this minus will turn out to be plus now. This is sine inverse 1. This is I is equal to root 2. 0 plus any number is number itself. And this is sine inverse 1. Sine inverse 1 is what? Pi by 2. Yes, it is pi by 2. So we got this as, we got the RHS only. This is what we had to prove, right? As I can see, this is what we needed to prove in this question.